Well, welcome back. Today our viewer writes, how was the order of draw determined? And how were the colors of the tubes determined? Well, that's actually a really interesting question. So let's look at the first question first. How was the order of draw determined? Well, basically what we're trying to do is to minimize the interaction from one tube to another. So in other words, we're going to take the most sensitive tubes and go to the least sensitive tubes. The most sensitive tube we're going to have are the various culture tubes, including the SPS sample. And the reason for that is that none of the stoppers have been sterilized in the rest of the draw. Every time you put a tube onto that needle, you run the risk of adding a contamination which could add bacteria to your culture tubes, which we don't want to see. Within the culture tubes, there are two different main types of tubes that we have, aerobic and anaerobic. We always start with the aerobic because there may be a little bit of air in the system, particularly if you use a butterfly. And so if you're going to have air, you want to be that into the aerobic tube. The other reason is that the first sample you draw is most likely to be the most complete sample, and aerobic tubes are much more likely to have a good result or a useful result compared to an anaerobic tube, which is a much lower yield rate. The next most sensitive tube is going to be the coagulation studies. And so that's why the second tube you're going to draw is the citrate tube. Now I said we're going to start with the second tube. If we don't have cultures, we actually draw a discard tube first. Typically we're going to use a clear top, but you might use something like a citrate as a disposal. But if you use a citrate as a disposal, then you have to make sure you know which one is which when you actually put your labels on. The reason for that is what we don't want is the coagulation cascade to have started. The longer the needle's in the body, the more likely that the coagulation will have already started. And when we first put the needle into the body, we're injuring the tissue, and those injured tissues will start off the coagulation cascade, which is why we need that discard tube first. The next set of tubes we're going to get to are what I'm going to collectively call sort of the red top tubes. And we've got three different ones which would fall into this family. The very next one we're going to use is the royal blue tube. And the reason for that is that this is used for trace metal analysis. Every time you put something onto that stopper, perhaps one of the other stoppers may have contained a little bit of a trace metal, and so you might contaminate this tube, which is why you want to get the royal blue as soon as you can. So this would be the royal blue tube with no additive would come next, followed by your red top tube. Now historically, when we had glass, a red top tube had nothing in it. It was equivalent to the clear tube that we use nowadays. But since we've moved to plastic, well, plastic doesn't start the coagulation cascade well enough. And so all these tubes actually have to have additives in them to actually start the clotting cascade. And then the third one of the red top tubes would be your gold top tube, which is simply a red top tube that has a little bit of gel. Again, as we go through, we're trying to go from most sensitive to least sensitive, and why add the extra complication of that gel if we don't need it. The next types of tubes we're going to get to are going to be your heparin tubes, the green tubes. And again, what we're going to use is the non-gel followed by the gel tube. Then we get to one of the more complicated tubes, and that's going to be the EDTA tubes. First, we're going to use the royal blue version, and then the straight EDTA. The reason that EDTA has to come relatively late in the process is that EDTA is a chelator. That means that it binds various positively charged ions. For our purposes, as an anticoagulant, well, it's calcium, and it's going to stop the coagulation. But it does bind to other things as well. Things like magnesium, copper, iron. And if you get into those, well, those are cofactors in some enzymes. And so the EDTA can actually rip those out of those enzymes and destroy their activity. And that's why a lot of the times in chemistry we cannot use an EDTA tube. But also very small amounts of EDTA, while it may not affect the calcium and the clotting in the other tubes, that may be just enough to destroy some enzyme activity, or as we discovered in a ward in Surrey Memorial, where a ward was using intentionally the wrong order of draw, well, it actually caused them to have falsely low iron levels. So after the EDTA, then we're going to go on to the black tube, the ESR tube, because it's really unaffected by any of these other things. So we can put it relatively late into the process. That's followed by the ACD tube. While it is a citrate tube, we don't use it for coagulation purposes. So again, we can push this towards the end of the series. Then we're going to get to the gray top tubes. The gray top tube contains fluoride. Fluoride is a poison for the glycolysis pathway. So basically, it's going to stop glycolysis. That's good if you want to control the level of glucose, but it's bad for pretty much everything else. And the reason is without glucose, the cell has no energy and the cell will die. A cell that dies is going to release its contents. And so it's basically the equivalent of hemolysis that is happening in these cells. We don't want to see that, which is why we need to make sure that the gray top tubes come very, very late in the process. Then we get into things like the NIPT tubes and the TB-IGRA tubes. And the reason is we're now into very, very obscure assays, which are relatively unaffected by all of the problems that we may see with earlier, so we can put them towards the end. The very last type of tube we come to are the various specialty tubes typically used for nucleic acid studies. The reason that these are at the end is the nucleic acid studies are relatively unaffected by all the other contaminants or clotting that we may see, so they can be towards the end. And many of them also have various unusual types of additives which have not been well studied, and we do not know how they'll interfere with some of the other assays that we do in the lab. So that brings us to the other part of the question, which is actually a really fascinating story. Prior to 1949, all blood draws were drawn by syringe. In 1949, BD introduced to the world the evacuated collection system that we're all familiar with today. Already in 1949, they were using the current colors. I've talked to several people within BD, and unfortunately, the reasons for those choices are lost to the mists of time. When BD moved to the current HemoGuard system in 1990, they basically transferred over the same colors, which is why we still have the same colors that were used in 1949 if you're using BD. Greiner was one of the next companies to come online, and they ended up choosing colors which were relatively similar to BD's, so we don't actually see a lot of complications in terms of the color choice. And in BC, where those are the two companies that dominate the market, we're relatively unaware of the fact that in other parts of the world the colors are not standardized. Oh, there was an attempt to do this. Back in 1995, ISO came up with a new guideline recommending a world standard. It's fairly close to what we see, with some very subtle differences, and some of the colors are missing. That document was eventually withdrawn, and in North America, NCCLS, which is now we now know as CLSI, introduced their new guidelines in 2003. These guidelines were developed in cooperation with BD and Greiner, so it's no surprise that the North American standard colors are what we're used to seeing today. Unfortunately, in 2007 and 2010, they revised those guidelines, softening their color recommendations. In fact, they no longer even have color recommendations. Meanwhile, in Europe, in 2004, they developed their own guidelines. Their guidelines did not list any colors, so they don't have any colors standardized either. And so while this is not an issue here in British Columbia, in the rest of the world, there are over a dozen different manufacturers, and they certainly do not have standard colors. But it gets even worse. Some manufacturers will custom build you tubes. You can specify whatever color you want. So there are some referral labs receiving tubes from one different company that have come from two different hospitals, and they use different colored tops on them. So there's still a need for standardization in the world. It's just in BC we're insulated from this because we are following something which basically defined the world standard.